Hello, this is Mr. Sindel filling in for the sick Miss Anderson. I'm going to be going through problems 1 through 25 in the practice final. So when you're watching this video, make sure that you have a piece of paper pulled out because I'm going to be writing down some important things that you can have for your note sheet that you can use on your final. Let's get started. Number 1. We're trying to write each of these expressions in exponential form. So we're getting rid of the radical symbol here, and we're just going to have some powers. This is the rule that you need to write down on your paper. So go ahead and pause the video or whatever if you need to. But this is going to be, if I have the square root symbol or the radical symbol of anything, this anything, I'm just going to do parentheses. And I'm going to say the root is b. In this case, it would be 3 over here, but I'm just going to keep it general. B, and it's all going to be to the power of a. This is the same thing as that anything, the same anything on the inside, to the power of a divided by b. Remember, a divided by b, that's everything in the power. And you can go back and forward with this. You can go to the left or you can go to the right, and that's why I do 2 arrows there. So this thing needs to be written on a piece of paper. This will help you out immensely on the final. Let's use this rule to solve number 1. So I know that this anything on the inside, 3n, is going to be this anything over here. So it's going to be 3n, and it's going to be to the power of a over b. Well, I know a was the thing on the outside, so that's 5. So this is going to be to the power of 5, and then it's going to be divided by whatever this index was, this b. So it's going to be divided by this 3, divided by that 3. And there's our final answer. It's going to be 3n to the power of 5/3. And you don't need parentheses here. I did that just to make sure that you could see the relationship between the rule. And that is our final answer. Let's box our final answer. Moving on to number 2. It's the same exact rule. So we have our anything inside, this 3m squared. So I'm going to rewrite that 3m squared. That's going to be our base, 3m squared. All right. It's going to be to the power of, oh, look, there's nothing right here. When there's nothing right there, you always assume it's going to be a 1. Okay, so this is 3m squared is going to be to the power of our a. In this case, this a is 1. And it's going to be divided by b, so it's going to be divided by this index, which is 3. So this turns into 3m squared to the power of 1/3. Final answer, box it. Again, using the same rule. Again, this one is a little bit tricky, kind of like number 2, where we have something that isn't explicit. Whenever there's no number, there's no index, you always assume that this index is 2. It's the square root, not the cube root, not the 4th root. So when I take this problem and I try to convert it, I'm going to take this inside, the 7a. That's going to be my base, 7a. It's going to be to the power of this a comes to the numerator in the fraction for the power, so it's going to be to the power of 5, and then I'm going to divide it by whatever this index was, 5 divided by 2. Final answer, box it. Perfect. Moving on. Okay, same exact rule over and over again. So we have this inside, this base. This is going to be 2x. And then what power is this? Oh, we don't have a power right there. It's blank. We always assume that that blank power is a 1. So it's going to be to the power of 1. And then divided by the denominator in the fraction is going to be this index, which is 6. Final answer, box it. All right, moving on to questions 5 through 8. So in the last questions, we went this way. We are going from a radical sign and getting rid of it to get to exponential form. Now in these problems, we're going the other way. We're going from this to this. All right, so what do we have here? We have, this is our A, this is our B, and then this is our base that we're using. Okay, so just, I've labeled everything. I just need to come to this form on the left now. So I have my anything on the inside of the radical sign. So I'm going to make my radical sign inside here, 10p. Okay, the A, the 7, remember the A comes up to the top. It's still on the power. So it's to the power of 7. And then the 6, that comes into the index. That's right here, 6. And we have the 6th root of 10p to the power of 7. Final answer, box it. All right, let's apply it to number 6. We have our A, our B, and our base. So our base goes inside the radical sign, so we have an x, and then the A stays where it was, so 5 stays in the power, and this 2, the denominator in this fraction, is going to come from the index. So it's going to be the square root of x to the power 5th. This is fine. You'll get full points for saying this, but this is the same thing as just the square root of x to the power of 5. Remember, if you don't have anything written, it's assumed to be 2. Both of these are fine. This is the preferred form. On to number 7. So again, we have our a, our b. That b is a little bit bad. Let's try to rewrite it. B, and this is our base. So it's going to be our radical symbol. Our base goes on the inside. Our a, our 5, stays in the power. And then the 4 is going to become the index. It comes right there. Final answer, box it. Coming over here, so just same thing over and over again. So a is 5, b is 3, and then here's our base. So it's going to be the radical of whatever the base was, 2v. And then the 5 remains where it was, to the power of 5. And then this 3 becomes the index. It goes right there. Final answer, box it. All right, number 9 and 10 are the same type of problems as number 1 through 4. So again, the rule that you should have written on your paper already is that if you have a radical sign with something on the inside, the index is b and it's to the power of a, that can go back and forth. It can change forms with this, where you have a base to the power of a divided by b. Okay, so again, we have a radical form, we have the form on the left, and we're trying to get to the form on the right. This is called the radical form, this is called the exponential form. So I'm going to label what everything was here. So this 4 is b, this 5 is a, and then everything inside of the radical sign, this is called the radicand, this is 5n. Okay, so we have 5n, remember it's whatever's in parentheses for our base, and then it's going to be to the power of a divided by b. So this is going to be 5 divided by 4. 5 divided by 4. There's our final answer. Box it. Okay, same thing for number 10. We have our a, we have our b, and then we have what's on the inside, the radicand. And we just need to set it up in this format. So it's going to be m for the base, and it's going to be to the power of a divided by b, 5 divided by 3, to the power of 5/3. Final answer, box it. All right, for number 11, we have a very similar format. So we have something that is in this form where it's a fraction, and we need to first get it into a radical form and then simplify it. So simplify is a lot more to do in mathematics. You have to do a little bit more work. So let's take a look here. We have this form on the right, this fractional form, this exponential form with a fraction in it. So I'm going to label what we have. We have an a, I can write that a little bit bigger, an a b, and then our base, of course, is 64. Okay, so I'm going to go back into this radical form, and then we'll see what happens from there. So it's going to be 64 inside of the radical symbol, of the square root symbol. So our radicand is 64. And then our a, our 1, stays where it was. And our b turns into the index. So this is going to be 2. This is the same thing. I can simplify this a little bit, because remember, if you have, oh, that was a bad arrow. Let me try that again. So this is the same thing as the square root of 64. And if you can't see that, the reason is if you have a 1, that 1 goes away. Anything to the power of 1 is that anything. And then whenever you have a square root, that's the same thing as having 2 in the index. So that 2 can disappear. The 1 and 2 can both disappear depending on where they are. So now you have to ask yourself, do you know the square root of 64? Square root of 64 is 8. So this is equal to 8, because 8 squared is 64. Our final answer is 8, box it. Okay, number 12. So it's the same thing. We have this exponential form with a fractional exponent, and we need to get back to this radical form. So let's go ahead and label it what everything is. And this is going to be a for the numerator, b for the denominator, and our base, we're going to put that in parentheses. Okay, so rewriting it in this form, we have the 64 as the radicand. That's going to be inside the square root symbol. And then our a is going to be left where it was, so it's going to be to the power of 3. And then that 2 comes down to become the index. Perfect. Okay, so remember, whenever you have a 2 for the index, that can just disappear, so we can get rid of it a little bit. So this is going to get turned into the square root of 64. Ooh, that seems familiar, right? And then that's all to the power of 3. And you can do whichever one you want first. And in this problem, I don't need to explain that too in depth, but you can do the square root first or you can do the power first. This one, it's definitely clear that we want to do the square root first because square root of 64, that looks like a nice number. Square root of 64, as we saw in number 11, is 8. So this thing right here, everything in parentheses that I just put there, we can solve that. So it's going to turn into 8. But we haven't dealt with this power of 3 yet, so we have to rewrite that. 8 to the power of 3. Okay, now we need to figure out what 8 to the power of 3 is, and if we don't know what that is, then it definitely helps to have some paper. So 8 to the power of 3 is the same thing as 8 times 8 times 8. So I know 8 times 8 is 64. I mean, that's how we got the square root of 64. So this problem really boils down to, it's the 64 times 8. And I'm going to do that on paper really quick. So 64 times 8. 8 times 4 is 32, so 32. And then 8 times 6 is 48, but I have to add the 3, so it's going to be 51. 512 is the answer of 64 times 8. So this final answer is 512. Final answer boxed. So moving on to problems 13 and 14, we need to graph these exponential functions. I know that they're exponential functions because this variable, the x, is in a power. If it was down and not a power, like 2 times x, then it would be a straight line, a linear function. But it's not, it's in the power, which means it's going to be some form of curvy graph like this or like this. But before we even begin, I want to cover 2 basic facts that you need to have on your note sheet. So the 2 facts, let's go over here to a new page. And I'll do these in red to let you know that these are the things you definitely need on your note paper. So fact number 1 about graphing exponentials. And if you want to title these, you can. I don't think it really matters, but I guess the title of these is graphing exponentials. Exponentials. Okay, when we graph exponentials, we make a table. And when you make a table, it's really important to know 2 basic properties about how exponents work. The first thing is the 0 power rule. So if I have anything to the 0, so if I have anything here to the power of 0, this will always, always, always be 1. And I'm going to change colors here to let you know that you don't need to write this, but if you want, you can. I mean, it's always nice to have extra notes. As an example, if you have one, I don't know, a big number, what is this, 100,000 to the power of 0, that's 1. If you have negative 1, 2, 3, all of that to the power of 0, that's equal to 1. Anything to the power of 0 is 1. Okay, pretty straightforward. You hopefully already know that. The other thing that you need to have, and this is the trickier of the 2, is what happens when I have a negative exponent. So if I have some base, I don't care what it was, but it's to the power of like negative, let's keep it general, negative a, and I'll show you some examples in a sec just to make sure we know what we're doing. This is going to be, I'm going to have to flip it. This was all over, and I'll put this over 1, 2 in my notes. This was all over 1. It's the same thing as saying 3 over 1 is the same thing as 3. I can have anything over 1 as an integer, or any number really, and it's the same thing as just it without being over 1. But coming back to here, going not on a tangent, I'm going to flip these 2, flip, and then this a is going to become a positive. So this is now going to turn into 1 over whatever it was to the power of positive a. You're supposed to flip. And just as a quick example to make sure we know what we're doing, if I have 2 to the power of negative 1, this is the same thing, and I'm going to do some markup here, so I'm going to change colors to let you know. This was the problem. The markup I would do as the student is I would say, okay, well, that's the same thing as 2 to the power of negative 1 over 1. It's the same thing. I haven't changed anything. You're allowed to divide by 1. And now I'm going to flip these 2. I'm going to flip, and I'm going to get 1 on the top and 2 to the power of something on the bottom. And now because I flipped it, this negative 1 becomes a positive 1. This negative a became a positive a, so it becomes positive 1. And that's the same thing as just 1/2, because 2 to the power of 1 is just 2. Another quick example, just to make sure we know what we're doing. Let's do 3 to the power of negative 2. So as a student, I come and say, okay, well, that's the same thing as 3 to the power of negative 2 over 1. I can flip these. The numerator becomes the denominator. Denominator becomes the numerator. This is going to turn into 1 on the top and 3 to the power of, oh, not negative 2, it's now a positive 2. And I can simplify that a little bit. 1 stays on the top. 3 to the power of 2 is 9, so the answer here is 1/9. Okay, if you know these 2 rules, you can graph these problems. Okay, let's do this. So there's one thing that I want to put on the note card as well, and it's just to label a general formula. Now that we got here, those two rules were for graphing exponentials in terms of the table. So I'm going to actually add to this. Sorry about that. In terms of the table, and now this is in terms of an equation. So the equation rule. If I have y equals, and let's just keep it general. We'll say some number. So I'm going to put, let's just say a, and then times another number. We'll just do b. And this b is attached to the power of x. The one that is attached to the power of x, this b, that is always going to be affecting if it's going up or down, if it's going to be growth or decay. So this is, I'm just going to say up or down because that is probably easier than growth or decay. Up or down. This is the growth multiplier, or there's a bunch of words for this, but it's essentially affecting the shape. It's either going to be this shape or it's going to be this shape. This b affects the shape. This a, however, this is always going to be the y-intercept. Okay, so with that in our note card, we're going to come back and add to this in a sec after we hit problem number 15, but that's the basics that I want on your note sheet. So coming back here, I'm going to make a table, and that's why we had these rules. We're going to make a table, and then here are our x values. I should switch colors. This is not needed on the note card. This is needed to solve the problem. So x and y, right? So the values that I always choose for x and y, I always do -1, I always do 0, and I always do 1, but it also helps to have a few more points. It also helps to have a -2 and a 2 as well. It just makes it clear what the graph looks like. But definitely -1, 0, and 1. Okay, from there, I need to plug in -2 into the x. Remember, this is saying that x is equal to -2. So I come over to the equation, and I say, well, that x should be -2. When I do that, and I'm going to do my scratch work just right here in the center column. Hopefully we can follow that. So this is now y equals 4 times, I'm just rewriting this equation now, 2 to the power of, instead of x, it's now -2. -2. Okay, now you're going to ask yourself, okay, what the heck is 2 to the power of -2? And you come back to your notes and you say, oh, I have a negative exponent. I'm going to divide it by divide it by 1, flip it, and make that a positive instead of a negative. So this is now going to be y equals, don't touch the 4, leave it alone, 4 times, okay, this was 2 over 1. I'm going to flip it. It's now going to turn into 1 over 2, and this -2 turns into a positive 2. Positive 2. Now I know what this is. 1 over 2 squared is 1 over 4, because 2 squared is 4. So this is, I'll be very meticulous in showing my steps. Y equals 4 times 1 over 4. And 4 times 1 over 4 is just 1. Y is equal to 1. This is the same thing as 4 divided by 4, if you couldn't follow that. Y is equal to 1. So I can fill in my table, that was 1. And we need to go through each of these 4 other problems as well. So I'm going to do that really quick. Let's open up a new sheet over here. And I need to do what happens when I plug in a -1. I'm going to rewrite this equation. So it's going to be y is equal to 4 times, and it's going to be 2 to the power of -1. Okay, I need to deal with this negative power first, so I'm going to divide it by 1. This is going, and I'm going a little bit faster, I know that, but it is a video, you can watch it later if you need to. Y is equal to 4 times, I'm going to flip it, so it's now going to be 1 over 2 to the power of +1. This is the same thing as 1 over 2, and then 4 times 1 over 2 is the same thing as 4 divided by 2. You just multiply straight across. This was 4 over 1 times 1 over 2. And you multiply straight through. 4 times 1 is 4. 1 times 2 is 2. 4 divided by 2 is equal to 2. I come back over here and I say, okay, my answer, go back to blue, was 2. Okay, here's a shortcut for 0. Of course, you could always plug in 0, and I'm going to show you that really quickly as well. But the shortcut for 0, whenever I have 0 for the x, the answer is always a. This is the y-intercept. The definition of the y-intercept is where it crosses the y-axis, or where the x value is 0. Look, the x is 0 there, so this value without an x attached to it must go right there. Let's check that though. So I'm going to plug in 0 into this equation on my scratch sheet. So I'm going to have this next problem, y is equal to 4 times 2 to the power of, and it's not x anymore, it's 0. Okay, remember our rule over here where we said anything to the power of 0 is 1? We're using that rule now. 2 to the power of 0, that's 1. So then now this turns into y equals 4 times 1. 4 times 1 is just 4, and that's our answer. If we come back over here, we can check our work. This was indeed 4. Perfect. By now you should have hopefully seen that there is a pattern here. 1 goes to 2, 2 goes to 4, and this is always going to be the same pattern. You're always multiplying by something. You're always multiplying by either a fraction or an integer. In this case, I'm multiplying just by 2. 1 times 2 is 2, so times 2. 2 times 2 is 4. You can probably guess what the next number is going to be because it's the same pattern. Times 2, this should be 8. And then times 2 again, that should give you 16. And these are indeed correct. You could do the math for that, but I'm not going to. This is a shortcut. I'm showing it to you. Use it on the final. All right, so from here, we graph it. So I have x is equal to negative 2. I'm going to come over to negative 2 in the x direction. So right now, I'm right here. I'm not going to make a mark yet for a point. I went to negative 2, and I'm going to go up 1. There's my point. Okay, so check that one off. Good. Let's go to negative 1 in the x, 2 in the y. So negative 1 is right here, and I'm going to go 2 in the y. So there's my next point. 0 to 4, so 0 in the x direction. I don't move. I stay on the y-axis, and then I go all the way up to 4. 1, 2, 3, 4. It's actually labeled. Perfect right there. And just keep making points. 1, 8. 1 is right there. Come all the way up to 8. 2, 16. There's 2. Come all the way up to 16. And this is the hard part that I still struggle on, and I've been doing math for a while. We need to draw a curvy line that goes through all those points. Our best bet. I mean, if the line isn't perfect, you'll still get the points. Here's my graph. And here's my Mr. Sindel's pro tip. Draw a bunch of individual lines. Don't do it all at once. And it will eventually come, this should come down, out like this, and get closer and closer to the x-axis. And we do arrows on the end to let you know that it does go on and on forever. It doesn't just stop there. Perfect. Whew, a lot of work, I know. Let's try again on number 14. So again, we're setting up our table. X and Y values. Okay, so our X, I always like starting at negative 2, then negative 1, then 0, then 1 and 2. By the time I get to 0, I know what the pattern is, so it isn't that much work as long as I made sure that I did my first steps correctly. Okay, so we need to plug in negative 2. So I'm going to do my work up here. I think I have a little bit of room up here. It's going to get a little bit messy, but it should be fine. So y equals, I'm rewriting this problem, 5 times 2, 5 times 2 to the power of x. Well, x now is negative 2, so to the power of negative 2. Okay, let's deal with this 2 to the power of negative 2 first. So this is going to be all over 1. I'm going to flip it. So now my problem is y equals 5. I haven't touched anything over here yet. I am touching this part, so it is going to be flipped, and then I'm going to have a positive power. So it's going to be 1 on the top instead, and then 2 on the bottom. And instead of a negative 2 power, it's to a positive 2 power. And this is the same thing as 5 times 1 over 2 squared is 1 over 4. 1 over 4. And remember, when you multiply fractions, this is 5 over 1 times 1 over 4. You multiply straight through, and you're left with 5 on the top. 5 times 1 is 5. 1 times 4 is 4, 5 fourths. So we'll write that here. This is going to be 5 fourths. And if it helps you to graph this, which it might, this is the same thing as 1.25. You can do long division to figure that out if you need to. I just happen to know it off the top of my head. Okay, we need to plug in negative 1. So I ran out of room, so I'm going to go onto that scratch sheet. So it's going to be 5 times 2 to the power of negative 1. So y is equal to 5 times 2 to the power of negative 1. All right, so when we do this, we have y equals, don't touch the left-hand side yet until we deal with this negative power, this pesky negative power. So this is the same thing as divided by 1. We're going to flip it, so it's now going to be 1 over 2 to the power of positive 1. I'm going faster because hopefully you're picking things up now. This is also divided by 1. So this is just equal to 5 over 1 times 1 over 2. Multiply straight through. This is equal to 5 over 2. That's what we're going to put in our table, and that is also the same thing as 5 divided by 2 is 2.5. So I'm going to write both those things in our table, 5 halves and 2.5. Oop, I went the wrong way. So this is going to be 5 over 2, which is 2.5. So it might be hard to see a pattern. I can see a pattern, maybe you can too. I'm just going to do 0 to see if that pattern does hold true. So I'm going to come back over here. It's going to be y equals 5 times 2 to the power of 0. Anything to the power of 0 is, yes, you're right, it is 1. So it's going to be y equals 5 times 1, and 5 times 1 is 5. So we come back to our table and put 5 here. Okay, remember, the shortcut, we can check our work this way too. Whenever we plug in 0, it should be equal to the number without an x. This is a number without an x. It is equal to 5. Okay, good. We are doing it correctly. Do you see a pattern here? I see a pattern where these decimals get multiplied by 2 every time. 1.25 times 2 is 2.5. 2.5 times 2 is 5. So 5 times 2, that will give us 10. 10 times 2 will give us 20. Another pattern, I guess, is that this denominator is getting reduced by a factor of 2, and eventually that means that you're just multiplying by 2 either way. So same pattern, just a different way of looking at it. We need to graph these points. I go over to -2 in the x direction, and I go up 1.25, so a little above 1, so right about there. And now I'm going to go -1 in the x direction, -1, which is right here, and I'm going to go up 2.5, 2.5, looks right about there, 0, 5, so 0, 5, 110, 110, and 220, 2, whoa, that goes way up there. And again, do your best to make a curve that goes through this line. Lots of short little lines, looks the best. And remember that it does come a little bit flat over, okay, it's hard to do this. It comes flat over here like that. Okay, don't forget your arrows on the end to let you know it goes on forever and ever. Whew, a lot of work, but it was worth it. Nice little graph. And we're on to question 15. Okay, so 15, I did promise that we were going to add to our note card. So back here, we had this in our note card. And I said that this b affects the up or down, the if it's growth or decay. So now I want to add to our note card. So this b, when it is bigger than 1, so when b is bigger than 1, or if you don't like this greater than sign, you can write out the word bigger. When b is bigger than 1, and maybe I should write it under this graph, when b is bigger than 1, it looks like this. It's exponential growth. It goes up. So when b is greater than 1, it goes up. If I'm looking from left to right, of course. And when b is smaller than 1, it's technically when b is between 0 and 1, but I think just for the sake of simplicity, we'll say when it's less than 1, it goes down. Which means, look at this. This b was 2, and it went up. This b was 2, which is bigger than 1, and it went up. But now we have a b right here that is less than 1. It should be going down. This is just a quick way to check to make sure you're doing the right type of graph. Let's go ahead and make a table. It's the same method, and we'll see if that is indeed true. So, table method. We have our x and our y. We have our negative, oh, not -3, that's too far back. -2, -1, 0, 1, and 2. All right, just plugging these in. So, I'm going to do my work up here. Y is equal to 2 times, it's going to be 1/2. And that 1/2 is now to the power of -2. Ooh, it looks a little bit tricky. Let's see if we can do this. So this 1/2 to the power of -2. I haven't explicitly gone over an example like this, but let's do this one a little bit slowly together. I wonder if you can hear my son in the background screaming. He's having fun. So this is now going, it's already a fraction. Remember back over here where we had to write it over 1 to make it a fraction? We're in luck. It's already a fraction. It's 1/2. So now this 1/2 is going to be flipped. Oh, let me change the color here so we can see what's going on. This 1/2 is going to be flipped. So instead of 1 over 2, it's now 2 over 1. There's our flipping, and that 2 stays on the outside. It wasn't on the inside. It didn't get flipped. And instead of being a -2, it's now a +2. Just pause and think to yourself the differences between this problem and previous problems. It was already a fraction, so we just had to flip it, and this did not have to get flipped at all. It just stayed on the outside, and it did have the same rule where we changed it from a negative to a positive. Perfect. Well, now 2 over 1 is the same thing as 2, and 2 squared is 4. We didn't deal with this 2 yet either, so let me rewrite the rest of the problem. This was y equals 2 times all of this. So again, 2 squared is 4. 4 times 2, I might be going too fast. This is 2 times 4. 2 times 4 is 8. So this number here is 8. Okay, next trick. You don't have to memorize this. If you want to just keep doing the table, that will work. Here's a trick. This number, you're multiplying that number every time once you get a good number. So this is 8. 8 times 1/2 gives you 4. Or half of 8 gives you 4. Half of 4 is 2. And let's back up. We can check to make sure this is correct. Remember, this is the y-intercept. We have an x equal to 0. This should be equal to this number right here. And it is. This is working. So keep taking half and half and half. Half of 2, 1. Half of 1, 1/2. We're done with the table. That was way quicker than the previous problems. And hopefully you already knew that shortcut because that would make your life so much simpler. Okay, so let's graph these. -2, 8. -2, 8. -1, 4. -1, 4. 0, 2. 1, 1. And 2, 1/2. Right about there. And again, do your best to make a line, a curvy line that goes through these points. That was my best shot. And look, I promised that if b was less than 1, it would go down. Remember, these were going up, and now this one is going down. It is exponential decay. Perfect. So everything is matching the notes that we have. Let's go ahead and do a table for 16, and then we can be done with graphing for a while. So again, our table is going to have our x's and y's. Set that up. And then we have -2, -1, 0, 1, and 2. Okay, we need to get at least one number, and here is the next trick if you want it. So this trick says I'm going to start with 0, and this might confuse some people, so I'm hoping this doesn't happen, but I know what happens right here. At 0, it is always equal to this number, 1/3. I can just plug that in right there, 1/3. I know that rule. And then from there, to go down, whenever I'm going down, I'm going to multiply by this number. So multiply by 1/2. And this is where it gets a little bit tricky. You have to remember how fraction multiplication works. I started with 1/3, and I was going to multiply that by 1/2. 1/3 times 1/2. You multiply straight through. 1 times 1 is 1. 3 times 2 is 6. So the answer here is 1/6. Okay, and then to get to 2, I need to do the same thing again. I had 1/6, and I need to multiply it by 1/2 to get down here. It's just times 1/2. Same thing that we did to get from 1/3 to 1/6. We had to multiply by 1/2. So this is now 1/6 as your starting number, and we need to multiply by 1/2. Again, multiply straight through. 1 times 1 is 1. 6 times 2 is 12. So the answer is 1/12. 1/12. And that is a little bit hard to graph, but that's fine. These numbers are really where our bread and butter is going to be. They will be a little bit easier to graph, hopefully. Okay, so if I'm going up instead of down, I'm going to do the opposite of multiplying by 1/2. And this is why I'm hoping that I'm not going to confuse most of us. But this is a trick. We already know how to do the basic problem with the last 3 problems. But if I want to go the opposite direction, so let me do that with black or red. I'm just going to do it with red, I guess. When I go the opposite way, instead of multiplying, I'm going to be dividing. Dividing by 1/2. And you're probably saying to yourself, Mr. Sindel, that is way too hard. I can't divide by a fraction. Well, if you forgot how to divide by a fraction, I'll teach you once again. So there are 3 rules for multiplying by a fraction. Keep it, change it, flip it. This is for dividing by a fraction. And just as a quick, let's do an example. If I'm doing 1/3 divided by 1/2, actually, what problem are we actually doing? Yeah, 1/3 divided by 1/2. That's exactly what we're doing. This is the problem that we're doing. We're going to keep this number the same. So 1/3 stays the same. Change it. Change refers to the symbol in between. This was a divided by symbol. Change this to a multiply symbol. And then flip it. 1/2, the reciprocal of 1/2, the flip version of 1/2 is 2/1. That's how you divide by a fraction, and now you just multiply straight through. Multiplication is pretty straightforward. So 1 times 2 is 2. 3 times 1 is 3. The answer is 2/3. So if I come back over here, the answer is 2/3. And if I want to do the same thing again, so if I want to go up instead of down, normally we always go down. I take the opposite of multiplying, so it's divided by 1/2. So I need to do 2/3 divided by 1/2. So I have a new problem down here. It's going to be 2/3, and I should write them a little bit better. 2 divided by 3 like that, divided by 1/2. Keep it, change it, flip it. Keep it, 2/3. Change it. Divided is now multiply. Flip it, 2/1. Multiply straight through. 2 times 2 is 4. 3 times 1 is 3. Answer is 4/3. Oop, wrong direction. 4/3. Okay, these are a little bit ugly to graph, but do your best. Negative 2 goes to 4/3, so negative 2. 4/3 is a little bit bigger than 1. It's actually 1 1/3. So negative 2 comes up to 1 1/3. Negative 1 goes to 2/3, so that's right about there. 0 goes to 1/3, so right about there. And this is a funny graph. 1 goes to 1/6, which is almost on the line, and 1/12 is basically on the line. So that's our graph. And we do our best to make a line that goes through those points. Oh gosh, Mr. Sindel, you are horrible at making these lines. Again, come on, you got this. You got this. Okay, it's really hard with the technology. Whatever, I'm gonna call it good. Make sure that those points are nice and big so that your teacher can see that you do know where those points are, even if your line is not that great. This doesn't go back up. Technically, this line goes out forever and ever straight this way. And don't forget your arrow at the end. Perfect. Okay, so for number 17 through 20, you need to have this rule on your note sheet. And maybe you already memorized this, but we do need this. Okay, so it's going to be log with some base, we'll just say base b, of some number, we'll just call it in parentheses here. That is always going to be, if that is equal to a, then we need to say this changes to another form. And you can go backwards or forwards. So the other form is b to the power of a is equal to that anything. And I'm pretty sure you saw this rule in your textbook where that parentheses was an x. You can have it that way too if you would like. Let's use this rule to solve number 17. Okay, so let's identify what our numbers are. So this is our b, this is our parentheses, and we don't know what this is equal to, so we're just going to say that is equal to, we could do parentheses, I'm just going to leave it x. Okay, so changing the form here, it's going to be b, because it's base b here, b to the power of a is that x, so b to the power of x, why am I writing b? It should be 2 to the power of x, sorry about that. 2 is b to the power of x is equal to whatever was on the inside here, so it's 1/32. How do we get to a fraction? If you're thinking a negative exponent, you would be correct. So this is going to be 2 to the power of something negative will give you a fraction. And then what negative number should it be? We already know it's a negative, so x is going to be equal to something that's negative. How do I get to 32? How many times does 2 need to be multiplied to get to 32? And I'll give you a hint. Because we're in high school, it's just going to be some integer. It's going to be some whole number. It's not going to be some fraction yet, unless there's calculators involved, which there is not. So 2 times, and I'm just going to keep multiplying by 2 until I get 32. 2 times 2 times 2 is 8. Okay, well, multiply by 2 again. That's now 16. Oh, not quite. Multiply by 2 again. 16 times 2 is 32. So how many times do we have to multiply by 2? 1, 2, 3, 4, 5. The answer is -5. Remember, the negative came from the fact that it needed to be a fraction, and we just kept multiplying by 2 until we got to the number we're looking for, 32. X is equal to -5 is our answer. I guess it didn't really set equal to x, so really -5 is our answer. Moving on to number 18. Rewriting this form. So here's our b, there's our parentheses. So it's going to be, we'll say that's set equal to x again. We'll say b to the power of x is equal to 36. And I did the same exact thing again, where it's supposed to be 6 to the power of x is equal to 36. Okay, how do I get to 36 when 6 is the base? Well, this should look familiar. 6 squared is 36, so x is equal to 2. So our final answer is 2. Okay, coming down to number 19. Again, rewriting this. This is our b, this is our parentheses. We'll set this equal to x. So this means we're taking 6, finally did it correct. 6 to the power of x is equal to 216. Okay, well, now we need to figure out how many times to multiply 6 to get to 216. So 6 times 6, that's 36. Okay, we'll multiply by 6 again. 6 times 36. Okay, I have to do some scratch work here. 36 times 6. 6 times 6 is 36. 36. And then 6 times 3 is 18. 18 plus 3 is 221. 216. There it is. So it's just 3 6s. So I need to multiply 3 times. So x is equal to 3. Correct answer is 3. Moving on to number 20. Okay, again, this is our b, parentheses, set equal to x. So that means it's going to be 3 to the power of x is equal to 81. Again, what this question is really asking is, how many times do I need to multiply 3 by itself to get to 81? Okay, well, let's just try it. 3 times 3, well, that's 9, times 3 again. 3 times 9 is 27, getting close, times 3 again, and I do know that 3 times 27 is 81. So I need to multiply 1, 2, 3, 4 times. So it's going to be x is equal to 4. And since we didn't really have an x in the problem, we added that ourselves. We're just going to circle the 4, or box the 4. All right, number 21 through 24 is using the same rule where you have log base b of some number is equal to a. That gets changed into this other form, which is b to the power of a is equal to that anything. Okay, so we're using this. Let's set up a problem. So we have, this is our b, this is our stuff in the parentheses, this is our a. Okay, and then just rewrite it in this form. We're going from left to right. So b is first, so 256. And it's going to be to the power of a to the power of this thing to the power of negative 1/2. And we're going to set that equal to whatever was in parentheses, 1 over 16. Done. That's all you need to do. You just need to change it to the other form. Again, b, that's our parentheses, that's our a. So it's going to be the base, 121, to the power of whatever this is, to the negative 1/2. And that should be equal to the parentheses, is equal to 1 over 11. Next, we have our b, we have our parentheses, we have our a. So this is going to be 1/2 to the power of 6. So all of this to the power of 6. I'm doing parentheses to let you know that all of this is to the power of 6, not just the 1. And that is going to be equal to whatever was in parentheses there, which is 1 over 64. Done. Next one. This is our b, this is our parentheses, this is our a. So it's going to be 81 to the power of a to the negative 1/2 is equal to 1/9. Done. And I should be boxing each of these because these are our final answers. So please do box all of them. For number 25, the last problem in this video, it's using the same exact rule where you have log b of some number equal to a. That changes into this other form. You can go backwards or forwards into b to the power of a is equal to that anything. All right, so now we're given this form on the right and we need to go to the form on the left. So let's label what we have. We have a b, we have an a, we have our anything. So we have everything set up, just go back into this form. So I have to rewrite the log. It's going to be base b, so base b, b was 4, so base 4 of parentheses, parentheses was 64, 64, and that's set equal to whatever a was. A was 3. Done, box it. And that concludes this video. Thank you for watching.